Okay, example 3-3 is looking for a relationship with minimum specific energy and critical depth. So for a channel with a triangular cross section, so we have a triangular cross section, and the slope is for one vertical, you have m horizontal. So this is water surface, and then you have the water depth, y. So the question asks us to show that the minimum specific energy is 1.25 times of the critical depth. So we want to show that a minimum is equal to 1.25 of YC. So for rectangular cross section, it's 1.5 times of YC. So what we have here is energy equation. So we know that energy equation E is equal to Y plus Q squared divided by 2G A squared. And in critical flow condition, we know that Froude number is equal to 1. So if you want to use Froude number for any cross sections, so we need to use the general formula for Froude number, which is Froude square, don't forget the square value here, is equal to Q square T divided by G A to the power of 3. And in critical flow condition, this is equal to 1. So if I rearrange this equation, then I can isolate Q square. So Q square is equal to G A to the power of 3 divided by T. And then I can use this expression and replace it with Q square here. So now I'm going to have a minimum because I assume that the Froude number is equal to 1. So because I assume that Froude number is equal to 1, now the energy is minimum energy is equal to critical depth plus, now instead of Q square, I'm going to use GAC to the power of 3. So it's critical area divided by 2G AC square times TC. Okay, so now gravitational acceleration from numerator and denominator cancels out. Here I have T to the power of 2. Here I have area to the power of 2. I have AC to the power of 3. So these two cancel out. And what is left is AC. Okay, so then the equation is reduced or simplified to YC plus AC divided by 2TC. Okay, so we also know that area divided by tau width is equal to hydraulic depth. So I can also write it down as YC plus DC divided by 2. So DC is hydraulic depth. So in any general cross section, you can also write down that the minimum energy is equal to critical depth plus half of the hydraulic depth. Now, I know that the relationship between cross-sectional area in triangular cross-section, so for triangular cross-sections, so the cross-sectional area is equal to my square, and the tau width is 2my. So I'm going to use that in energy equation. So a minimum is equal to YC plus MYC squared divided by 2 times 2 MYC. Okay, so YC squared and YC cancels out. So you are going to have YC here. And then M and M cancels out. And then 2 times 2 becomes 4. So we are going to have YC plus YC divided by 4, which is 1.25 YC.